Yet again, I am going to use the box to multiply this out. If you know the pattern, you can use the pattern, but I want to use the box to show it, as I think it will make it clearer. So now we have the square root of 8 minus the square root of 7 and the square root of 8 plus the square root of 7. So the square root of 8 times the square root of 8 is 8. Square root of 8 times the square root of 7, well, gee, what is 8 times 7? That would be the square root of 56. Similarly, this one over here is going to be minus the square root of 56. And now, last but not least, down here on the bottom right-hand corner, one of them's negative, so it's negative, and the square root of 7 times the square root of 7 gives me 7. Okay, so now I have like terms here that I can combine, and when I do so, 8 minus 7 is 1. And I have like terms here that I can combine, and lo and behold, they cancel out. One of them's negative, one of them's positive. Magnitude is the same. The square root of 56 minus the square root of 56 is 0. We don't need to write it. So this whole thing simplifies to 1. I'd like to say one more thing here before I forget, and that is that there's a useful property right here. Notice that the radicals all went away. We can utilize this when we want to rationalize a denominator if we have a binomial radical in the denominator of the fraction, on the bottom of the fraction. We refer to these two, which are the same except that one's plus and one's minus, as conjugates. And if we multiply by the conjugate of the binomial, the radicals cancel out and there are no radicals left, only a whole number. Very useful in rationalizing the denominator of a fraction.